So now we're going to introduce our amazing first speaker. I'm going to give her a lot of energy. We have Vallery Lancey. So Vallery is a developer and systems lead at Checkfront. She specializes in cloud and distributed systems and has a passion for leadership and spreadsheets. So very rarity there. A couple fun facts about Val. She loves guinea pigs.
She taught Michael Jackson how to moonwalk.
She's had over 10 different hair colors.
She climbed Mount Everest twice.
And if you want to give her a really warm welcome, your first speaker today, Vallery.
Thank you, everyone. I'll leave you to guess which of those are true and which aren't. So before I really get into things, who has worked with Kubernetes before at all? Okay, a handful of you. Who doesn't even know what it is and they're just here because it's advanced? All right, suspected so. So it's a very difficult thing to teach very quickly. I've kind of come up with one way of getting a lot of the basics, but because we're in the advanced track, a lot of it is going to be, I'm going to show you some things, I'm going to explain a couple things, and then you go home and you Google more. But that's kind of our jobs. In this room, we all understand that. So if anyone is planning on actually going through with the demo, now would definitely be a good time to make sure you have everything pre-installed and you have a cluster running, just because that can take a little bit. I'm not going to leave time for that later. So first thing, we're going to introduce just a very primitive and only semi-realistic application. I'm going to look at the basic concepts of what Kubernetes actually does for us and a little bit of how it works. And then I'm going to step through setting up the application. And finally, look a little bit at kind of some of the stuff that we either skimmed over or didn't have time for that you will realistically see when you're dealing with real deployments. So I've created a basic Go HTTP API. It doesn't use any state. It's basically just a hello world of web applications. So Kubernetes, especially for those of us who aren't familiar, is a deployment manager and container orchestration tool. So you give it some containers, and it deals with the actual logistics of how many does it run, where does it run them, how does it connect everything up. It's really helpful at big scales and for very fast responses. So it can fail things over and scale things up far faster than a human can, especially when that human is perhaps a phone call and a sprint away. It also lets you create a very clear divide between the people who are kind of running the infrastructure and systems side and the application side. So who's familiar with kind of that nasty back and forth where a developer needs to do something in production, but they don't have production access, and they need to tell a sysadmin who doesn't know what they're doing? Yep. It's a situation that really sucks. So the more we can enable developers to push things out without giving them like various critical security access, the better. Containers, which I mentioned earlier, most of you probably know what they are. The order is actually a little bit silly because right after me is the container talk. They're basically a very lightweight abstraction around processes to let you isolate a process in the system as opposed to having full access. So it has its own version of the file system. It has an isolated namespace. It has isolated resource access. This lets you pack lots of different process trees into one system without having them interfere with one another. So in some ways, you could consider it analogous to VMs, but another layer down. Big warning, though, because people compare them to VMs a lot, containers are not inherently secure. They're not inherently insecure either, but depending on what runtime you're using and how you configure things, it's definitely possible to bust out of them. So orchestration tools deal with the workload of we have some containers, now how do we actually deal with running them? So declarative config is particularly popular and useful right now. Instead of saying, I want you to change the system like this, you say, I want the system to be like this, and there's a feedback loop of making sure that the reality of the system matches your specification. For example, you don't say, add 2 more containers. You say, I want there to be 4 containers, or I want there to be 6 containers. and the system deals with making that so. So if some die, they come back. You don't have to manually bring them back. You can also change lots of other aspects of the spec like that. If you want to give something more or less resources, you just do that by saying what you want the deployment to be, and the system corrects things to make that the current state. There's also a lot of networking abstraction. So traditionally, we have one very long-lived machine. We have an IP address going into it, and that IP address is that machine, and it's that deployment. Here, because everything is ephemeral and dynamic, we have specifically a DNS system set up within the cluster. So you connect to an abstract concept called a service, and that maps to some random instance. So you don't need to worry about tracking the individual copies of things that are going up and down, because that would be very messy for a developer to worry about. Almost done the overview. So we have just a very simple diagram of the architecture here. We essentially have the Kubernetes master system, which deals with the actual scheduling, logistics, and management. There's an API for it, and it controls individual nodes where we schedule our workloads. Nodes look roughly like this. So we have the internal components down in kind of bluish purple there, and then we have all the pods that we actually want to schedule, as well as potentially abstractions on top of that. So who's had trouble getting an application to work in Kubernetes before? Surprisingly few hands, given a bunch of you know Kubernetes. So it's not so much that Kubernetes is hard as that software engineering is hard. If you want to make anything that isn't very long-lived, single VM, stateful, you need to adapt. So in the past, I've spoken on this before because there's a lot of assumptions around traditional software engineering that don't really fly when you want to be able to use a system like this. Although a lot of the assumptions don't fly when you want to go to production, period. But like I mentioned earlier, there's kind of that split of, oh, no, we're good. There's that split of developers make it work on their laptop. They pass it off to a sysadmin, then it's the sysadmin's problem. We want to avoid that because developers need to deal with the kind of reality of what they're supposed to build. Okay, so there's kind of your quick primer. A lot of you probably are already familiar with that. Now we're actually going to look at setting up a simple application. So to get our application up, here's kind of the minimum of what we want. We need to get our container images together. We need a cluster to work on. We want to deploy the application. We want to be able to map inbound network access to the application so anyone can ever see it. And then we'll kind of look at one extra, which is adding autoscaling. So let's get going. First thing, and I'm going to be doing this off of the console, so we'll see how well this goes. We want to have a container up. So I'm going to get my repo. This always takes a moment. All right, so now I've got my content. I want to build the container image. That text size isn't great. How far back can people actually read that? Oh, maybe I just have bad eyesight. So I have a pre-built image if anyone wants to follow along, just because I strongly suspected, at least from my memory, UVic Wi-Fi, not great for uploading and downloading a lot of content. So once this completes, we'll push this up to a registry. This means that instead of just sitting around somewhere, it's in a location where the cluster can actually access the image and pull it down when it wants to create a copy of that container. Whoops. All right. Okay, I pushed it up, and it mostly already exists just because I have something pre-built as a failsafe. Uh-oh. Let me just get this back. We're going to be bouncing back and forth a lot between looking at YAML, the slides, and the console. So I've already pre-set up a cluster just because that can take a couple minutes, and I've had bad experiences in the past with trying to create one on stage and then getting the API version wrong or something. In this case, we'll be using Google Kubernetes Engine. So Kubernetes is very nasty to try to run yourself. Not impossible nasty, but like you want systems people for it nasty, not just something you do and then forget about. So there's a lot of managed services right now. Basically, every big cloud system has one where they deal with the logistics of running the Kubernetes infrastructure itself so that you just deal with your high-level management and your actual applications running on it. So let's look at actually deploying that application. So who's familiar with deployments, as in the Kubernetes concept? Really? There's definitely some missing hands. So deployment is a spec for what you actually want to run. It contains a list of containers, what the spec for those containers should be, as well as some spec about the unit as a whole. So a deployment creates something called a pod, which is just the instance of a deployment. A pod is a group of containers that are scheduled together and live together. So they're directly adjacent on a machine if you want very, very quick latency, and they have shared state. So for example, you might have an application and its cache as two separate containers within the same pod, or an application and its web server proxy. I'll bring up an example. That's not good. I'll bring up the example deployment config. That projector's making me nervous. So we give it an identity, API. We specify how many replicas we want. And then we have the actual spec for the individual contents. In this case, we just have one container in the pod because I'm keeping it very simple. So in this case, we specify which container it is, go API. We give it the image, which is that container image that I just pushed up earlier, both the name and then the tag at the end, one, which is an identifier. People usually use those for versions. We also have an environment variable. So who's dealt with something like secret management tools before? You usually don't want to bundle all of your settings and secrets in an application itself. In fact, you definitely never want to bundle the secrets, but I know some people still do it anyway. So There's two concepts, environment variables and secrets in Kubernetes, that are used to decouple that kind of runtime setting from the actual container image. In this case, I skipped secret, but I have environment variables and I can still explain secrets. Environment variables are basically meant to be non-secret configurations. So it might be the endpoint address of an API that's supposed to connect to, or the parameter of its cache size, something to that effect. In this case, we have a message that will be used in the API. If we want to use a secret, it's quite similar. We create a secret, or the cluster admin at least creates a secret as an abstract resource, and then we have configuration that says the secret as a file should get mounted onto this part of the file system. So from our application's point of view, there's just a file it has to read. And that way, local developers or a dev environment can substitute in whatever values they want. We've also got our resource limits down here, last of all. That is extremely important because things can run away in production. And with multi-tenancy, runaway in production has escalating consequences. Still don't have our console back. I might not bounce back into presentation view just because there's so much back and forth. So we have our deployment file, we have our container image pushed. Now let's actually deploy it. Default way to interact with the cluster is with a tool called kubectl, which is kind of the official CLI. There's a lot of ways to interact with the cluster. There's the official dashboard, there's third-party dashboards, there's custom APIs. kubectl is just kind of the go-to. Whoops. Uh-oh. All right, we're good. So let's use kubectl to actually push up that deployment. We can't access it yet, but we can see that it's running. So we're going to use kubectl apply for this. Apply is a very nifty function, which is basically the make it so of deployments. This deployment, if it doesn't exist, it'll create it. And if it already exists, it deals with making whatever is already deployed fall in line with our spec. So again, we don't have to worry about making imperative changes of, I want you to change this. We just say, I want you to be like this. And the cluster deals with making that happen. So now we've deployed that. There's a couple ways we can check up on the health of that to make sure that our deployment's actually launching okay. The most native way is just to go kubectl get deployments, and I see, it's already up. So no crashes, no complex boot times. We can also look at the individual pods if we want more information about each instance that's running. There, nice and simple. So it's running now, but how do we connect to it? We have that abstraction I mentioned earlier called a service. Oh boy. So services map an abstract DNS name, usually the name of an application, onto some random instance in the backend. This means that you don't have to track where exactly you're routing something, just what an abstract you want to connect to. They're used both for mapping inbound requests from the outside world, and they're used for mapping things within the cluster. So say you have a postfix server in your cluster for sending email notifications. You would set that up as a postfix service that whatever parts of your application send mail would connect to internally. So I'll bring up the service config now. Service config is typically very simple. All right, well, GitHub doesn't seem to want to load. Okay. Yeah, so like I said, quite simple, especially because we're not doing anything out of the ordinary here. In this case, this is pretty much a straight pass-through of we want our API service to go to our API deployment. There are circumstances, which I'll talk about in a sec, where this does get more complicated, but a lot of the time it's not much. Where things do get complicated is something called the ingress, which is when we actually want the outside world to interact with some of our software. So the ingress acts as a map between some endpoint, typically a load balancer, and one or more services in the cluster. The ingress lets you put rules on things. So for example, a common situation is to use HTTP routing rules in the ingress. So you can specify /API goes here, /assets goes here, the main route path goes here, and so on. One of the things that makes ingresses a bit finicky is they are heavily integrated with whatever handles the load balancing and network management. So this means that they're very specific. For example, right here we're using the Google ingress. There's an Nginx ingress. There's an Amazon EC2 ingress. There's many of them. So the rules and quirks and what you can do for the configuration tends to really vary, and that's part of why I've kept the ingress simple. This is kind of what the structure looks like. So we have our ingress with rules, and it maps onto individual services. So this way we have one unified point to connect to what's actually distinct things in the cluster, rather than needing to build one monolithic service, although you can do that perfectly fine. So as seen on the right, we typically have a one-to-one relationship between a service and a deployment, but we don't need to. Do you recall the label specifier in the deployment earlier? That's basically an abstracted identifier that services use. So services don't map onto a concrete deployment, they map onto a label. In this case, I told my API service to map onto the label API in deployments. I apologize, there's a big mistake in there. One of those APIs should not be v1. The point that I was trying to show is that one way that you can manage rollouts versus an all or nothing is basically canary testing, dipping your toe in the water by creating a small deployment of a new version. Say you have 8 replicas of one, 2 replicas of the other. To the service, they're all the same thing. So this means that I think 20% of the numbers I gave would go mapping to the new version. This means that if your new version is going to crash and burn or your users are going to complain about it, you get to know about that before subjecting every single user to it. So now let's actually deploy those two things. Service is very simple. Ingress sometimes messes up because, as I said, it's very integration heavy. All right, so the service is set up and, excuse me, the service is set up and now things can technically connect to the application, but they do that by routing through individual hosts, and that is still very concrete and dynamic. So we want something that's abstract with the ingress so that we can just point our DNS record to one place and know that it's going to work. Okay, so that's starting to create the ingress. The ingress typically takes 2-3 minutes to come up just because it's also going to create a load balancer that's attached to that. So we can see that starting up. I'll bring up the ingress config as well. So this is a very simple ingress just because we're mapping everything onto one API endpoint. I've commented out there, typically what we do, I just trimmed it out for time, is we create a static IP address in our platform and then use an annotation to specify what it should be. Right now, this is using an ephemeral IP address. So I don't know what the IP is going to be until the cluster is created and the load balancer is created. We don't usually want that. So reserving something in advance and using the annotation makes sure that we know what the address is going to be consistently. Down here in the spec section is where we would specify our rules. So in this case, we just have the default backend only. But if we wanted to separate it out to have multiple services, we would specify some path mapping onto some other service as well. So I have a shorthand in here to let me check what's going on with the ingress and when it's ready. Looks like it is ready. We get an IP address out of that. So if I take that IP and connect to it, I should get the API message. Or not. So what that usually means is it means that something hasn't spun up yet. As I said, ingresses do tend to take a while, so we can check on the actual load balancer and see what's going on. So it looks like it doesn't have any backends. I'm just going to check on that quickly. Looks like the ingress is still creating. I'm going to jump back to that as opposed to waiting for it. Again, like I said, this can be a slow step. So last thing we'll look at that's concrete is autoscaling, which is kind of the biggest and shiniest feature. Unfortunately, autoscaling isn't automatic, although that's kind of fortunate because how do you want to autoscale? Really depends on what exactly you're doing and how your app works. We use a precise target in deployments of exactly how many replicas we want. So if we want to autoscale, we either manually or normally use the built-in autoscaler to change that deployment target based on the health of the application. So the horizontal pod autoscaler is the built-in way to do that. It essentially checks some kind of metric, by default the CPU usage, but you can define anything custom that you feel like, and will bring up or bring down the replica spec depending on how that's going. So if your application is seeing more use, it creates more copies, whereas if it's seeing less use, it creates less. So for the autoscaler, we specify what we want to be scaling, the API, and then we specify what the replication bounds are and what we're using. In this case, we're going to be going between 2 and 8 depending on CPU load, and we want to target an average 50% in each one. 50% is probably below lockup point. I'm sure you can get to about 90% in this app before you actually see slowness. But you want to give yourself always leeway so that if your traffic spikes up, you don't have to wait 45 seconds for the app to respond to it. Let's get back into the console. So I'm going to look at my pods now. If you recall, I believe there was either 3 or 4 copies of the deployment earlier, but now I've specified that it can go as low as 2 under low load situations. So yeah, right now I have 4. In a moment, next time there's an autoscaler check, it's going to drop down to only 2 because we have, unless someone's running Gatling at it secretly, nothing really going on. All right, ingress still isn't up. So always something live, no matter what happens. Again, I'll try to jump back to that. Oh, here we are. So autoscaler is kicked in. If I were to put a bunch of CPU load on it, then we'd suddenly see 2 or 3 or 4 or 5 replicas come up to compensate for that. That also couples with node autoscaling, which is done at the cloud platform level. So you don't just have to have machines or VMs sitting idle waiting for things to expand. You can outright make sure that more VMs are created when suddenly the system wants to schedule more containers than it has room for. So I feel like I'm about on track time-wise so far. There's a lot of things that I didn't have time to get into because this is an introduction and Kubernetes is hard, I'll say it straight up. So the nastiest thing that the average person has to deal with is state. What's hard about state in a dynamic environment? How do we replicate it? Where does it go? How do we make sure we're not throwing it out all the time? So the easiest way to deal with a state is, first off, just not do it in Kubernetes. For example, right now I'm working on a proof of concept for a very legacy application, and our database is running in a VM, just because I don't want to deal with Postgres right now. So you can use a database as a service or just a VM in the local environment, and that's nice and easy. There are ways that you can sanely run one copy of something, but if you only have one copy, you're still going to be, for example, power cycling it every time you push an update, and you don't usually want that for a database. The ideal situation, depending on what database you're using and how much time your operators have, is to use Statefulsets. So a stateful set is like a deployment with a couple extra features. Essentially, it creates a stable identity between pod instances and their resources. So for example, instead of just getting a storage volume that matches the given criteria, it maps onto the same storage volume every time. So for example, this makes sure that your database primary always gets the right disk, as opposed to just being given some random disk from another database replica. And also allows you to order the creation and termination, so you make sure that like your application level replication happens properly. Beyond that, like as I said, this is the advanced track, so a lot of learning anything is knowing what to Google. End-to-end encryption is super important because there's still a lot of lateral access within the cluster. Right now, there's a lot of really cool stuff in the space called service meshes, which are a little bit overblown, but let you do some really neat things, including native end-to-end encrypted transport between services. There's also things up and coming like Specifies and Spire that let you handle even more granular authentication between various workloads. However, until we hit about 2020, a lot of the time you're going to be working with Nginx or Stunnel as a proxy to make sure that your traffic is actually encrypted before it leaves a pod. Kubernetes is largely an ops domain, but it's also a dev domain. So for example, service and deployment config, and probably ingress as well, devs should be setting that up because they're the ones who actually know how the application should be running. API is extremely flexible. Please don't bash script kubectl for tooling. Don't do it. Use the API. If you want to use CI and CD, use the API. If you want a custom deployment manager, use the API. Don't script kubectl, please. It's my plea to you. And lastly, there's lots and lots of cool features and abstractions that you can build into. In the words of Joe Beda, Kubernetes is a platform. It's something that's best for building abstractions on top of. So if you want to manage your deployments in a fancy way or create a high-level view of your application beyond all the individual things that compose it up, there's lots of things you can use, such as operators or custom resource definitions, to natively bake those concepts into Kubernetes, as well as any kind of abstraction that you want to place on the API. From the admin side, running a cluster is really hard. You basically want a systems person no matter what. And realistically, at like startup Victoria scale, you don't want to run your own cluster. You want to use some kind of a cluster as a service, because this takes out a lot of the day-to-day admin work and lets you get started in 5 minutes as opposed to 5 months. Cluster security can get really nasty. If I could give you just one tip, it's do not let anything access the master nodes. So you want to firewall any kind of access to the API server, and you want to be really careful about what kind of lateral node-to-node or pod-to-pod access is allowed, because the con of having something that's kind of all one big shared bubble is you get that lateral access for any kind of attacker. So you want to cut down that lateral access so that someone getting their foothold into, one little abandoned service in the corner doesn't mean that they can get into everything. Lastly, RBAC, role-based access control. It's an extremely powerful tool for mapping out exactly what someone can do on what resources and in what namespace. So instead of giving some person or a tool cluster admin, you can simply use RBAC to give them exactly what they need. So I can create and update deployments in the dev namespace, and that's it, for example. I'm losing my breath here. Very last, the docs are really good for finding out what to do. There's a lot of ways to do anything in Kubernetes, which means that sometimes you will do things a bad way that works but isn't great. For example, there's multiple ways that you can roll out updates, and some of them are easier and some of them are more flexible. Let me just check and see if this ingress is finally. Yep. So took a while to spin up on the Google side, but we have that. So you see that environment config is what I specified in the deployment. If I want to change that message, all I have to do is edit the deployment and reapply that, which I can actually probably do very quickly right now. This is very high latency here. So all I'm going to do is just kubectl apply that again. Now we have pods in a bunch of different states. What's happening is we're creating new instances of this new deployment. As we do that, we start tearing down some of the old instances. And once something passes the readiness probe and is properly booted up, traffic will start getting routed to it. And then correspondingly, it'll take down one of the old instances. So this means that the application doesn't seem to power cycle. It looks seamless from an outside perspective as long as we have more than one pod. Which I think it's more than 3 is the ideal. There we are. So everything's switched over, and now, there we go. We are Victoria. And lastly, a reminder, if you're doing the demo, the stuff can get expensive if you leave it on. Please remember to turn it off. So delete the cluster, delete your container images. Google's load balancer gets deleted with the cluster. I don't know about other platforms, so also check on that. All right, question time. So if you have general questions, I'll certainly take those. And if you want me to show you basic things, like how do I do changes to the image or something, or how do I try to alter the service, I can try to show those things.
So this is going to sound super basic. Can we get access to these slides post-workshop?
Yes, so I believe Startup Slam is going to post a copy.
Oh,
I've already submitted a copy at least.
Okay, cool.
Perfect. That was the first one, and that was the highest ranked question. Thank you,
Yes.
Jay.
Yeah,
Can I have the slides?
I apologize. It's a lot of content, and I know I've went through it very quickly.
No, it's good. This is really cool tech. So I'd
It's-
love to sit down and actually
I was speaking with my team member last night. It's so hard to pick what content makes the cut because there's like 3 times this that goes into the typical app.
All right, so I know a lot of people don't like speaking in front of other people, so I have tons of questions for you, Val. Thanks so much. I think this is really cool, Slido. So if you guys have any presentations that you do, even for your classmates or anything, sometimes this is a good way to get good, thoughtful questions. So here we go. Curtis asks, are all APIs in Kubernetes intended to be HTTP, or can you have an STP server living in a container?
For running your own workloads, you can run anything you want. So you can use layer 4 or layer 7 ingress, where layer 7 is normally HTTP, but layer 4 TCP, or I guess UDP, you can also use. So if you want to have like a database, SFTP server, like you mentioned, you can do that too. It's just slightly different ingress config and different load balancer config.
Any follow-ups to that one, Curtis? No? Okay.
Next question. In your resource limits, the CPU was 50 over 100 M. Could you explain further what the M means and how that's comparable to, say, someone who only understands processors like i3, i5, like 2 gigahertz, 2.5 gigahertz, so on and so forth?
Yes, so the CPU limits are meant to be percentage of a thread. So specifically 1000 M is the equivalent of using a full thread. So it doesn't map onto so much actual processor speed, it's just processor's percentage. So when I say use 100 M, I'm saying I will give you 10% of a thread scheduling time. In this case, it's very tiny because we have a very simple API.
Any follow-ups? Well, okay, we'll move on. Kubernetes versus Google App Engine Flexible versus DCOS or DCOS. There's questions?
I'm actually not familiar with DCOS. A lot of it depends on how much flexibility you want and pricing and effort. So App Engine in particular is way, way more hands-off, but I believe it's more expensive to run. I actually haven't run it in production. And you are more region locked. So for example, with Kubernetes, you can do, May's sticking up his hand because I believe he's very familiar with this. You can do multi-cluster and an ingress between them. So you have a couple different clusters in the world, but you have some kind of shared ingress system so that someone in London or someone in Texas or someone down in Brazil sees the same application without having to necessarily make their request have a world transit. So advanced stuff like that is what's nice about Kubernetes, but the con is also the difficulty.
All right. Question from Steve. Kubernetes alternatives, are there any, and what's the best option right now?
The only flat-out kind of competitor I'm familiar with is, as far as like the same thing and not just more simple cloud platforms, would be Mesos and its family of abstractions. There's also like App Engine was mentioned. Elastic Beanstalk is a good example. More simple platform as a service. Aside from vanilla Kubernetes, there's also many, many Kubernetes abstractions. So there'd be that something like GKE, which is already definitely deviating from Kubernetes behavior, or platforms on top of that, like Giant Swarm, I think Rancher, stuff like that, if you want to see different behavior. Red Hat OpenShift, another really good example. They've very heavily changed what behavior looks like and added many new features.
So this is one that kind of follows up to this. So you mentioned Kubernetes and Docker Swarm, Mesos. What are the, this is from John, what are the use cases where Kubernetes, you would favor that one over the others? What does it do better? Why would you use it?
I would definitely, I mean, this decision doesn't make sense for everyone certainly, but personally, like with the stuff that I do, I would favor it over the more simple platforms as a service just because of the multi-region support and the ability to do advanced control. So for example, gradual rollouts is a huge feature as far as being able to work in a production environment. Versus, sorry, what were the more, Mesos, Docker Swarm?
And those are the two that he listed.
Yeah,
But
so part of my choice is around project velocity and maturity, but it's kind of down to preference and exact feature set. I certainly wouldn't say that Kubernetes is the best out there, but I think it serves most use cases quite well. Best is hard to quantify because everyone needs to do something different.
Next question, also from John. How does Kubernetes compare to ECS if the goal is to run containers on AWS? What are the trade-offs?
ECS is AWS's container platform, right? So I don't know much about the details of ECS. Could I maybe get a quick fill-in on how that behaves?
I believe the ECS is just like App Engine standard environment, so you just supply with a container image and then it just does stuff. Like you still have to spin up your own like load balancers and like provide all the items that it needs. But essentially it's just like App Image. Sorry, I just want to like steal the thunder a little bit. I was at Google Cloud on board on Thursday and the exact same question was asked about Kubernetes and App Engine. And one of the engineers sort of allegedly slipped out that the App Engine is powered by Kubernetes in the background.
Not surprised. I mean, Kubernetes is based off of a system called Borg that Google built internally quite some time ago to manage their internal workloads. I mean, yeah, in that case, it boils down to, do you want simplicity or flexibility? And that's kind of a decision that depends on what you're doing and what your scale is.
What's our next one? This one's from James. Is supervisored built in as the Kubernetes supervisor, or can other supervisor programs be used?
I don't know about that specifically, but almost everything is meant to be modular as far as what particular service implementation you use. So that might be the case, but I'm not familiar specifically with swapping out supervisor D.
Is Kubernetes the Ansible for containers?
I guess you could say that. The answer really is not quite. It's definitely analogous in that it's a mass management system, but Ansible is much more manual. So unless you have something very silly with scripts and crons, Ansible isn't going to continuously manage your fleet. It's just a deployment tool, whereas Kubernetes manages the whole life cycle.
So this one ties in a little bit earlier when you talked about flexibility and costs and what you're looking for. So what are the costs to Google, for example, besides cluster VM costs? Is there any other costs?
So do you mean what money are they sinking into running GKE?
What does it cost to deploy?
For the end user?
Yeah, for me.
Yeah, so you pay for the actual, it just uses normal compute engine, so you pay for whatever compute engine instance it spins up. You don't pay for the master. Google just eats that cost. So you only pay for the worker nodes you spin up, and you pay for any load balancers that you create. So it basically just creates normal, actually, and like potentially persistent disks as well. So it basically creates normal Google Cloud resources that are priced according to standard pricing. There's nothing very mystical there, beyond how all cloud pricing is mystical.
Braden asks, are there any specific resources you recommend for learning more about Kubernetes?
It depends where you're at. The Kubernetes Up and Running book is a fantastic jumpstart if you basically have like this level of information and not more. The docs, as much as it's boring to read them, are really powerful for the amount of both concepts and kind of use case work they provide. Beyond that, I'm not too sure about a good getting started resource.
Yeah. We've got Anthony asking, you mentioned encryption between microservices. How has this affected communication latency between containers?
I haven't benchmarked it in detail, but in practice, I haven't had an issue with it. You need to allocate a tiny bit more CPU, but not much. Encryption does have a hit, but there was kind of a bit of a myth that started like mid-2000s or so that if you try to encrypt your comms, it'll kill your speed. And people have kind of kept that up even though the technology and processors have come a long way since then.
Question from Steve asking about authentication for microservices.
So how do you want to manage authentication? I mean, that gets more into how you want to run your app versus Kubernetes, but there's a lot of different ways to do that. Spiffy and Spire is something I mentioned. It's a very advanced and still work in progress tool and spec to basically handle identities of every single individual instance of things. You can use JWTs, you can use, my preference is like a public-private key system where you create a public key that various things can use as their, hey, I am this service, and a private key of, as a cluster secret of specifically, I am this service, I want to connect to you. There's a lot of ways to do it, and it is fairly agnostic to like general app dev of how do you make any two apps communicate together.
Should be an easy one. What's the GitHub link for the project that you've been working on, and can you share that?
It is right there, though I realize not everyone can see it. It is github.com/VLLRY/startupslam-2018. So this should be posted once Startup Slam is done with all the resources. So it's not going to vanish.
I have a couple more, and then we'll open it up to the room if you've got some more questions.
Which industries will benefit from Kubernetes?
Basically, anyone who's running a lot of stuff is the short answer. So,
Hopefully all text.
so if you have high scale, if you have just like a lot of machines and you need to hire 20 sysadmins, if you have 20 different applications, which creeps up on you way faster than you would think. Yeah.
You do the last one.
Could Kubernetes be used to manage a personal local cluster or only for remote testing?
Certainly. So there's a tool called Minikube. I just skipped it here because, again, didn't trust the Wi-Fi and wanted to show something more realistic, where it's basically meant to be a developer tool where it creates just one node and a VM on your host. So if you want to do developer testing, you'd use that. And you can set it up like, I've been slowly tinkering away at doing it on old laptops for the last couple months. You can set it up on your own machines if you want. It's a lot of work, but if you feel like it. But at that point, you mostly have to have fun doing infrastructure and not just have a practical use case.
This might be the hardest one, so take your time in answering. Out of all 10 plus hair colors, which was your favorite and why? That's coming from me.
It was probably either the rainbow or the same kind of pink as I did on the slide backgrounds.
Very cool. So that looks like it's pretty much the end of the Slido questions. We want to open it up to the room. If there's any other questions that you have.
Yeah, so you're using kubectl for your stuff, and I'm wondering if you're using something like Helm at work, and how Helm would tie into not using like using an API, Kubernetes API to deploy rather than scripted builds.
Yeah, I haven't used Helm beyond like deploying someone else's apps just because I got so used to kubectl. I use a tool called KSonnet mostly, which is basically a scripting and templating abstraction. So you kind of write your YAML, but you get to specify higher level things like this is the deployment versus this is the dev cluster versus this is the staging cluster and stuff like that. So you're not in the weeds so much, and you can just say like KS apply to the whole app.
Thank you.
Did you ever consider Terraform for what you were doing?
Yes, I've looked at it before. Terraform, like, it really depends on what your goals are. I would kind of lay out like the cloud roadmap as Terraform is a step before because it's a way to manage your individual VMs. But again, it's more of a deployment tool versus a lifecycle management tool. So this offers things like the scaling concerns of not just like an admin wants to change things, but the system will change things.
If you're going to deploy a video on demand service, would you use a Kubernetes system or would you use a CDN of some kind?
It depends how much of the infrastructure I'm running myself. So obviously I would want a CDN. The question is just how do I build that CDN? Like personally, depending on pricing, I would probably just use like Amazon storage system, Google storage system or something, and just deal with a little bit of high level replication between those regions versus running my own nodes. But yeah. I mean, they tend to be, again, really depends on your use case and where you're trying to make the money. Third-party CDNs tend to be more expensive, but if that's like a side effect of what you're trying to build, you might just want to sink a bit of money in and not do extra development.
From someone, for us who make a video platform that has like millions of users trying to getting onto our learning and having playback and things, building your own, or generally when you're having that many users, like we're using Akamai right now, we're looking to move to CloudFront. So it all depends what your use cases are, what your security is, as well as regions is really important, how to deliver it to different people in different regions that have also different security requirements above and beyond just what the technology allows. It's whatever your customers allow you to. So some of them have different requirements where it has to be served from a certain point because they don't want their data, and then obviously latency, depending where it's coming from. Sorry.
No, that's a good Workday question. I can speak to generic app design, kind of.
Yeah.
They know video platforms.
Anybody else? With that, I want to thank you so much, Valerie.